So we are doing exponential functions and logarithms, and I'm going to be covering the knowledge portion of this. So to start, we're going to be looking at our log laws. So as a simple question, let's start with y equals 2 log 2x plus 3 log 2x minus 4 log 2x. So we're going to start by applying our power law, which means that the coefficients can switch places as the exponents on the variable, and vice versa. If there was an exponent here, it could be moved to the coefficient of the log term. So this equals log 2x squared plus log 2x cubed minus, log 2x to the 4. And now we're going to be applying our product laws and our quotient laws, which state the addition of log terms are multiplying the variables, and the subtraction is being divided by the variables. So to show you what I'm saying, this looks like log base 2. See, these are all log base 2. These only apply when all the bases are the same. We're multiplying because this is addition, so x squared plus x cubed equals x to the 5. And since this is subtraction, we're dividing x to the 5 over x to the 4 equals log base 2 x. So now what I'm going to have us do together, if you want to pause it and then do it on your own, is state the restrictions. So what we know is that in our basic logarithmic function, where x is positive, x must always be greater than 0. So that's the restriction on this. And now I'm going to go over converting between exponential and logarithmic form, because logarithmic functions are just the inverse of exponential functions. So if we have log base 2 x, converting to exponential form means that base 2, so we keep the base, to let's say, or this is equal to y. So 2 to the y equals x. Yep, and that's our exponential form. And for the purpose of evaluating, we're going to let x equal 16. So 2 to the y equals 16. We want them to be the same base. So 2 to the y equals, we keep the base 2, and to get 16 would be 4. Since these bases are the same, we know that y equals 4. So now we're going to be taking a look at adding translations to our function. So we have our base, y equals log base 2x. And we're going to be adding a vertical stretch of 3, a horizontal compression of 1/2, horizontal translation of 4 units right, and a vertical translation of 2 units down. So starting with the vertical stretch, y equals, the vertical stretch goes in front of the log. So if it were to be reflected over the x-axis, that would be a negative. But right now it's still positive, so we'll just go 3 log base 2. Horizontal compression, so we start with our bracket, and we know that the horizontal compression is the inverse of the k value. So if we want 1 over 2, we know our k value is 2. Bracket, then goes our x. We are translating to the right, so it is negative 4. Close bracket. And we're moving down 2, so to finish off, minus 2. And those are our translations. So now we're going to be looking at graphing our function with all of our transformations on it. So I find the easiest way to start is to create a table for our x values and our y values. So to begin, we know that our log function is the inverse of an exponential function. So we're going to set it up like that but we're going to replace what we normally put in the x, we're going to put it in our y, and then what the values of our y would now go into our x column. So a nice way to start, or easy if we're doing exponential or if we're doing logarithmic, is just putting -2, -1, 0, 1, and 2. And we're at base 2. So if we were to be doing exponential functions, we know that 2 to the -2 is 1/4, and moving down 1/2, 1, 2, and 4. And now we're just going to apply our transformations to this. So y is being multiplied by 3, and x is being multiplied by 1/2 because it's compression. So this becomes -6, -3, 0, 3, and 6, and this side becomes 1/8, 1/4, 1/2, 1, and 2. So we have our axes set up. We're moving 4 to the right, so our asymptote goes on x equals +4 rather. Make sure we label this x equals 4. And we're moving down 2 spaces. So this is where we're going to be starting from. So our x column, we move over 1/4, and then, or pardon me, 1/8 rather, because these are now not included. We're using these with our transformations. We move over 1/8 and then down 1, 2, 3, 4, 5, 6. And then over 1/4, and we move down 1, 2, 3, over 1/2, and we move down 0, move over 1, we move up 3, and we move over 2, 1, 2, and we move up 1, 2, 3, 4, 5, 6. So now we have our dots plotted, and we can now just connect the dots. Make sure you add your arrows onto your end, and that's our function graphed.
So today I'm doing a sample question on application. So for the sample question here, if Jane were to invest $2,000 of her money, the investment has a compound interest of 8% biannually. She wants to know how long it would take to double. So I have the equation here already set up. So 2,000 would be the initial cost, 8% for the biannually, and since it's biannually, that's every 6 months, so divided by 2, as well as 2 for the interest. So first off, you want to start off by solving it. So she wants to know how much it is doubled. So 4,000 is equal to 2,000 bracket 1 plus 0.08 over 2 to the exponent 2t. And then what you want to do is first divide out by the 0.08 divided by the 2. So then you're going to get 4,000 again is equal to 2,000 bracket 1 plus 0.04 exponent 2t. Then you want to continue to isolate for this t over here. So what you're going to do next is take the 4,000 divided by the 200,000 to isolate for the t. So then you're going to get 2 is equal to 1 or bracket 1 plus 0.04 to the exponent 2t. And then from there you can just add the 1 plus the 0.04, and then you're going to get 2 is equal to 1.04 to the exponent 2t. And now here where it gets a little tricky, you're going to log both sides to where the point you get log 2 is equal to 2t to log of 1.04. And then you have to bring that 2t over to the front of the log using your power or your log laws. Then from there you're going to want to divide the log 1.04 over and bring it over to here. So you're going to get log 2 all over log 1.04, which is going to equal to 2t. Then after that, divide these two out. You're going to get, let me just move that over here, 17.67 is equal to 2t. Then after that, just basically isolate for t, and you get that divided by 2, and this side divided by 2, and you get 8.8 is equal to t. Then you're just going to want to come up with a therefore statement. So therefore, Jane, after investing her money, it would take approximately 9 years for it to double. And that's it for part A. Now for part B. If Jane now wanted to wait on her investment for 10 years, how much money would she make? So she just wants to know how much moolah she wants to make, of course. So just set up the example or the equation here. Same as last time. So there's still the 8% over the 2 and still to the 2t. But this time, instead of just solving, putting the number in, you would just want to solve for the MT, which is money over time. So you will have the 10 years here, so you just sub that in for the t. So again, you just get 2,000 bracket 1 plus 0.08 over 2, and then 2 to the 10. And then now just continue to solve. So then it's 2,000 plus the bracket, and then 1.04 over 2, or that would be with the 2, and then 2 to the 10, which is necessarily just to the exponent 20, and just continue to solve here. And then after that, you can just do it all in one step if you'd like. If like that, then you would get $4,382.20 after the 10 years, what she would make.
So moving on to communication, our question is, assume log base 3 of negative a equals m. Is this possible? Prove and explain your answer. So I've already written the equation from the question here. So the first thing we can do is change this to exponential form to make it easier for us to see. So it would become 3 to the power of m equals negative a. And right here we can already see a problem because you can't raise 3 to a power and have it equal a negative number, negative a. So raising any positive number to any positive or negative exponent cannot be equal to a negative number. So we can also use domain and range to explain our answer. So let's say we have two equations, one being f of x equals log base 3 of x, and then another one, f of x equals 3 to the power of x. So we can say the range of 3 to the power of x is y equals 0, or y greater than 0, sorry. And the domain of f of x equals log base 3 of x is x greater than 0. So we know that these cannot be a negative number, so I'm going to write that. So because the range of the exponential equation is y greater than 0, the domain of the logarithmic equation is x greater than 0, because the domain and range always are the opposite. So therefore, neither can be a negative number. So in conclusion, we can say this cannot be this is not possible because a must be a positive value. And this is because the domain of the logarithmic equation is the same as the range of the exponential equation. And we should also note that these two equations are the inverse of each other. So there we go, we've answered the question.
Okay, so for part 2 of our communication, we have the question, Mark and Ryan solve the equation log 7 x plus 4 plus log 7 x minus 2 equals 1. Mark says the answer is x equals 3, whereas Ryan says the answer is x equals 3 and x equals negative 5. Who is right? Show your work. So we're going to solve the equation to determine who is right while showing our work. So we have log 7 x plus 4 plus log 7 x minus 2 equals 1. So we know that we can simplify this into one log by using the product law, which means that if the same bases are being added, we can multiply the brackets together. So we're gonna have log 7 x plus 4 x minus 2 equals 1. So now we know from prior knowledge of changing logs into exponents, we can change log 7 to the exponent 1. And on the right side now, the equation is x squared plus 2x minus 7 equals 7 to the power of 1, which just equals x squared plus 2x minus 8 equals 7. And now we can bring the 7 to the other side. So we'll have x squared plus 2x minus 7 minus 8 minus 7. Oh my god. And then we just simplify negative 8 minus 7. So we get x squared plus 2x minus 15 equals 0. So now we know this is a trinomial and we can factor this equation. So we know the factors are going to be negative 3 and positive 5. So we have x minus 3 and x plus 5 equals 0. So now we have that x equals 3 for this bracket here, and x equals negative 5 for this bracket here. So now that we have our values for x, we can go back and we can plug it into our first equation. So we'll get log 7, 3 plus 4 plus log 7, 3 minus 2 equals 1. And on this side, we can see that log 7, and that equals 7, plus log 7, and this, and this equals 1 equals 1. And then we know that log base 7 is 1. And we also know that this is going to be 0, right? Equals 1. So now we know that this is true. So x equals 3 is a value of x. And then we're just going to do the same thing for negative 5. So we're going to have log 7 negative 5 plus 4 plus log 7 negative 5 minus 2 equals 1. And so we have log 7, and that is equal to negative 1 plus log 7, and this is equal to negative 7 equals 1. So now we can take this and put it into exponential form. So we will have, for log 7 negative 1, we're going to have 7 to the power of something equals negative 1. And then we know that we cannot have 7 raised to something equal a negative number. So therefore this does not exist. This will give you an error. And for log 7 to negative 7, we're going to have 7 to something equals negative 7, and it's the same thing. So you're going to get an error here too. So therefore, we're just going to have a statement. Therefore, Mark was right. The only answer is x equals 3.
Okay, now we're going to do the last tutorial of the video, which is a thinking question. we're going to simplify using logarithm laws. These are our log laws, which are power law, product law, and quotient law. So when we look at our question here, we can see that all of the logs in the expression have the same base, which is y. This means that we can combine all of them into just one log and get rid of the plus and minus signs. So the first step is going to be using the power law to move the numbers in front of the log and make them our exponents. So we're going to move the 1 over 3x over, and we're going to have log base y m to the exponent 1 over 3x, which is the same as x over 3. Plus, we're going to move our 1 over 2 over, but before we do that, we're going to change our cube root into 1 over 3. So it's going to be log base y bracket r to the exponent 1 over 3, which is the same as cube root, and then our 1 over 2 here, minus log base y, we'll move our 6 over, and that's going to be multiplied by the 7t, so it's going to be m to the exponent 42t, plus, move our t over, log base y, bracket, another bracket, we're going to change our square root into 1 over 2, so L to the exponent 1 over 2, bracket, the t here, another bracket, and then the t that we moved over. Now what we want to do is get rid of all the brackets that we have, so multiplying all the exponents together. So the first one is good, log base y m to the exponent 1 over 3x plus log base y. We're going to multiply 1 over 3 and 1 over 2, and that'll give us r to the exponent 1 over 6 minus log base y m to the exponent 42t plus log base y L to the exponent 1 over 2 times t, which will be 1 over 2t squared. Now we can start using our product and quotient laws. So first we're going to do product law just to make it easier, and then we'll work on quotient law. So we have two plus signs in this expression, which means that this is multiplied by this and this. So all of that is going to give us log base y bracket our m to the exponent 1 over 3x times our r to the exponent 1 over 6 times our L to the exponent 1 over 2t squared. And then we have to add in our minus log y m to the exponent 42t. Now that we're done the product law, we can use the quotient law, which is because there's a minus here, which means that this is being divided by this. So our next line is going to be log base y, and the same as this in the numerator, bracket m to the exponent 1 over 3x times r to the exponent 1 over 6 times L to the exponent 1 over 2t squared over our m to the exponent 42t. And at this point, we look at the last thing that we have and see if we have anything that can cancel out, or if we can add or subtract any exponents, which we don't need to do in here. So this is going to be our simplified answer.